chassis of your car, right? So you're going to have bolt holes here, and you'll attach the whole thing to the chassis of your car. Everybody getting an idea of what I'm doing here?
You build that whole part?
Yeah, you're going to draw it in SolidWorks, and I'll show you.
What? There's like 2 standard sizes for the receiver. Which one do you prefer?
I really don't care for that part. You could choose either or. What I'm more interested in is, so let's say you can just remove that and put it whatever size you want with the bolt. So let's not worry about it. So you would draw the frame first, okay? And the frame is connected to your chassis via bolts. Okay, so you would first analyze those bolts using bolt connectors.
Thank you. Son of a... What's up? This little pin connector, retaining ring in without. So you want to do this one, physically make the pin. Physically make it. Yeah, you want to keep that one.
Okay. So this typically has a square, a hollow square cross section. And then this piece goes in here, and you'll have a pin connector right here. So you slide this in here, you'll have a pin connector. And you also have another bolt connector right here. Okay. So you have to do structural analysis of this member, and you'll have to apply forces in the hitch as well as detail there. So let me talk to you a little bit about structural members and how you draw it in SolidWorks, and how do you deal with welds, etc. So, let's say this is the approximate outline of this here. Okay. So let's get out of the sketch. All right, go to Insert or View, Toolbars, and select Weld Method. View, Toolbars, Weldments. Then in the Weldment toolbar, you'll see a structural member here. Select that. Select the standard ANSI or ISO. So let's say I select a square tube. And let's say it's 20 by 20 by 2. And I'll select this right here. Okay, and it'll give you part of the hitch.
Now, is that better to use or just easier? In the sense, I mean, you can draw that, it's fairly simple.
Well, here's the deal. It's going to, first of all, it does all the welding for you.
Okay, so that's considered welds at those corners?
Yeah, and this
Okay.
whole thing is treated as being elements. You're not so much calculating the stresses, but what are the 4 variables in the beam? Deflection, slope, shear force, bending moments. So you're only calculating those 4. You don't care about the stress analysis so much here, as though you're treating these as beam elements. Okay? So the whole process of solving is different. You're not doing a regular stress analysis. You're not analyzing, you see all these wells here? It will treat this as wells and it will actually analyze the well structure of wells here. And this is very useful for those of you who are in SAE. And anybody who's doing a project that involves cutting these members. So what you can do is, so let's say you make this, right, and you want to physically make this. All you have to do is, so you can buy the cross-section from McMaster and you send it to a machine shop. And all you have to do is, so you can click on one part that you want to make. And what you can do is, so let's say this piece is very hard to cut, right? So you don't have the tools to cut it. So what I'll say, I'll take that part and I'll say insert into new part. I have to save this.
What did you do to make that say stock part 1? Did you just rename that? Mine says structural member.
Yeah.
Other.
Anyway, you should be able to make a separate part from this. So let's say I do isolate for now. Anyway, you should be able to isolate the part, and if you can send the set part as is to a manufacturer, they can put it in their laser cutting machine and just, it'll take this part and it'll automatically cut it and send it back to you. So it'll be very easy for you. So if you're doing one of these projects that involves a lot of buying ready-made cross sections and chopping them up and welding them, you could do this. So anyway, let's go back to our drawing here. Okay, so I have this, and the next thing I'm going to do is I'm going to go back to my top plane here. I'm going to start a new sketch. Orient myself normal to the sketch. And I'm going to draw a line from the origin. Horizontal. Okay, so I have a line like this. And what I'm going to do is I'm going to add another weldment. So I'll select that line. I'll click on structural member again. And I will use the same thing. I'll do this. Okay, so notice that it automatically puts everything here. But it will extend a little bit into the part. And you don't want that, and you should trim this. So you can trim it like this. So there's a trim tool here. Okay, so bodies to be trimmed is this. It's right there. Okay.
Yeah, did that work? Is that supposed to have like a hole all the way through?
This one originally goes all the way through. If I isolate this part, let's say I suppress everything except that. I didn't go all the way through. Okay. Okay. Do you see how it trims like that? That's what that does.
If you want to go all the way through, just create an extended line, right?
Yeah. Okay. Okay, so this would be a basic structure for your analysis. Okay. Then you will create a separate piece here and do your bolt and nut connector. So for structural analysis of the cross section, you can use this. Okay. For stress analysis, you would still have to draw it the old-fashioned way. So if you want to analyze the welds, the cross section, and all those corners, and the bending moment, shear force, etc., in structural members, you can use this tool. If you want to analyze the overall stress and all that, you still have to draw it the old-fashioned way and do it. Okay? All right, so that's one tool. And so in your in Blackboard, you have a demo of how SolidWorks treats weldment and how it can calculate the different stresses. So let me show you that. Okay, so what this thing does is, so it automatically locates all the welded connections, and it knows the area of weld, etc., which you can also set. And what you can do is, I'm going to run this. All right, and it'll show you the displacement here. So what you could also do is, you could plot your shear force and bending moment diagram. So let's say I do define beam diagrams. So I can do a shear force diagram. I can do a bending moment diagram. And I can select a certain beam. So let's say I select this particular beam, and I can say, give me the bending moment diagram of this beam. And it will show you what the bending moment diagram looks like.
Wow.
So you could go
That's
analyze the
awesome.
bending moment diagram in each wheel, and you can actually get the value of bending moment. And you can also calculate the stresses, right? So you say list beam forces, and instead of forces, you can calculate stresses. So let's say I do SI for all the beams, 1 through 16. And it will give you sigma as NC by I, and tau is TC by J for each one of these. And when you buy this on McMaster, you can find out what the section modulus is and what the maximum permissible stress is, and make sure it doesn't exceed that. And this is how you analyze structures in SolidWorks. Okay? All right. The other thing I wanted to talk to you about is fatigue analysis. So how many of you have not taken machine design here? And of those who have not taken, keep your arms raised. Did you do any fatigue study in mechanics of solids? If you did, lower your arms. Did a little bit? You sort of familiar with the SN diagram? A little bit? Okay, let's talk a little bit about that.